On September 12, 2025, astronomers detected something that completely shattered their expectations about how the universe behaves. A colossal object was seen blazing in from the darkness of deep space, carrying a tail that stretched across the sky to a length 5 times wider than the full moon. It was so enormous and bright that even amateur astronomers with simple backyard telescopes could see it clearly. Within hours, observatories confirmed something shocking. This was no ordinary comet. It was far larger, far brighter, and far stranger than anything ever recorded. It was officially catalogued as C2025R2, but scientists and observers quickly began calling it Swan. What truly froze scientists in disbelief, however, was the timing of its arrival. Another mysterious object, already gaining attention among astronomers, was also racing toward the Sun. This object was known as 3I Atlas, and it was approaching from the exact opposite direction in the sky. Even more incredible was the fact that both objects were expected to reach their closest approach to the Sun within the same 10-day window. At the most critical moment, both objects would also be hidden behind the Sun's blinding glare, making them impossible to observe from Earth. The odds of 2 unusual cosmic visitors entering the inner solar system at the same time, from opposite directions, and disappearing behind the Sun at the exact moment of their closest encounter are almost impossible to calculate. Some scientists quietly stopped calling it coincidence. Instead, a more unsettling word began to circulate among researchers: mission. One strange interstellar object arriving would already be extraordinary. But the arrival of a second object, potentially 100 times larger, moving through the same solar corridor suggested something much more unusual. Some researchers even began wondering if we were not witnessing random astronomical events at all, but the unfolding of some kind of operation. As more data poured in, scientists noticed something unusual about Swan almost immediately. It wasn't just its enormous size that stood out. It was its behavior. Normal comets scatter light in predictable patterns as ice and dust vaporize under the Sun's heat. Swan behaved very differently. Its reflective properties suggested the presence of metallic elements such as nickel and cobalt, the same materials humans use to build strong, corrosion-resistant alloys. Because of this unusual composition, some researchers started calling the object the Fortress. The nickname came from the way Swan appeared to survive the intense stress of approaching the Sun. Most comets begin to break apart as they heat up. Swan seemed almost protected, as if it was shielded. Its brightness stayed far higher than what natural ice and dust could normally produce. Even its enormous tail behaved strangely. Instead of spreading out like chaotic vapor, the tail pulsed with subtle rhythmic changes, almost like small bursts were pushing or adjusting its movement. Imagine watching something the size of a giant structure drifting through space like a massive armored tank, surrounded by a glowing halo that might not simply be gas, but something more complex, perhaps even an electromagnetic shield protecting it from the violent solar winds. That is the image scientists are now struggling to understand. Even more unsettling than Swan itself is the behavior of its smaller companion, 3I Atlas. If Swan resembles a fortress, Atlas behaves more like a drone. It moves quickly and unpredictably, showing strange bursts of acceleration and sudden changes in the color of its tail that natural comet activity cannot easily explain. When scientists examine the two objects together, they do not appear like random cosmic visitors. They look like two parts of the same system. When astronomers plotted their arrival paths on a star map, something extraordinary became clear. Swan appeared to come from the direction of Aquarius, while Atlas came from Sagittarius, two regions separated by more than a quarter of the sky. Yet despite their very different approach angles, both objects entered the inner solar system at nearly the same solar distance and reached their closest approach to the Sun within just 3 days of each other. Statistically, this kind of synchronization should not happen. Normally, comets appear at random times, sometimes decades or centuries apart. They scatter across different orbital paths and arrival periods. But Swan and Atlas were arriving almost together. Then came the blackout window. Between October 8th and October 18th, the Sun's intense brightness would prevent telescopes from observing the region where both objects would be located. Their closest moment to the Sun, and to each other, would occur during the exact period when Earth's instruments could not see them. To many scientists, this looked less like coincidence and more like coordination. Two unusual objects arriving together, disappearing at the precise moment when their true interaction might occur. In orbital mechanics, astronomers sometimes refer to this kind of alignment as a corridor, a narrow window in space and time where paths intersect. Whether by chance or by design, Swan and Atlas appeared to share exactly such a corridor. This possibility forced scientists to consider a question that had once seemed too speculative to ask. What if these objects were not simply passing through the solar system, but actually converging for a purpose? While orbital mechanics raised troubling questions, the energy measurements raised even greater concerns. Atlas had already shocked researchers by showing sudden bursts of acceleration that looked remarkably similar to controlled thrust. Each burst required energy comparable to the output of 10 nuclear power plants. But Swan made those numbers look small. Estimates suggested Swan's energy output could reach nearly 10,000 gigawatts, more energy than the entire electrical grid of Earth. No natural comet nucleus could generate that level of power. Comets normally release energy by sublimating ice under sunlight. Nothing about Swan's energy output matched that process. Its metallic reflection, its glowing halo, and its rhythmic pulses suggested something very different. Some scientists began quietly discussing the possibility of engineered propulsion, plasma bursts used to steer a massive structure through space. Even more curious was the timing of those pulses. They were regular enough to resemble signals and structured enough that some researchers began wondering if Swan was not just a fortress, but a beacon. If Atlas was behaving like a drone that maneuvers and collects data, Swan might be something much larger, a mothership designed to survive immense journeys through interstellar space. Calculations suggested Swan might follow an orbital cycle of more than 22,000 years. That would mean its previous appearance in the solar system occurred near the end of the last ice age. This possibility sent some scientists looking back at ancient archaeological sites and historical records. One place that suddenly gained new attention was Göbekli Tepe in Turkey, an ancient site containing stone carvings that depict mysterious celestial symbols and spirals. Some researchers speculated that these carvings might represent observations of unusual comets or celestial objects in prehistoric skies. If Swan had appeared thousands of years ago, it might have been seen by early human civilizations and remembered as myth, prophecy, or warning. As the world's curiosity grew, something else began happening: silence. Space agencies such as NASA, the European Space Agency, and others began restricting high-resolution data releases and reducing public updates during the most critical observation period. Officially, the explanation was routine solar conjunction downtime, a standard safety measure when observing objects close to the Sun. But the silence only fueled speculation. Independent astronomers and amateur observers began organizing their own tracking networks, using private telescopes and shared data channels to monitor the objects as long as possible. Meanwhile, Atlas continued displaying unusual behavior. Over several weeks, 3 sudden accelerations were recorded. Each burst occurred sharply and unexpectedly, almost like clockwork. Each burst also coincided with a strange shift in the color of its tail, from red to neutral and back again. Natural comet outgassing happens gradually as sunlight warms the surface. Atlas's behavior looked sudden and controlled. At the same time, Swan's gigantic tail showed its own strange behavior. Instead of expanding randomly, it pulsed with small bursts that appeared to adjust its trajectory with precision. One object small and agile, the other massive and powerful, yet both seemed to be maneuvering deliberately within the solar system. Their closest approach points were only about 50 million kilometers apart, closer than the distance between Earth and Mars. For comet observers used to centuries of data, this situation was unprecedented. Some scientists began considering unusual possibilities. Perhaps the Sun itself acted as an energy station where the objects could recharge. Others suggested Atlas might deliver collected data to Swan during their close passage. Another possibility was even more unsettling. Swan might serve as a transmitter, sending information somewhere far beyond our solar system. Spectroscopic analysis from the James Webb Space Telescope added another mystery. Instead of the normal mixture of ice and rock expected in comets, SWAN's spectrum showed complex organic molecules known as polycyclic aromatic hydrocarbons. These molecules are considered building blocks for life. Even stranger, the molecules appeared unusually refined and structured. This led some scientists to wonder whether SWAN might not simply be a machine but possibly a carrier, transporting organic material between star systems. Another unexpected observation soon followed. SWAN was not just reflecting sunlight, it was emitting radiation in a rare frequency band between soft X-rays and gamma rays. Natural comets do not normally generate structured emissions like this. The pulses appeared deliberate. Around the same time, amateur satellite trackers reported detecting a burst of energy from SWAN aimed not toward Earth, but toward the Moon. The signal appeared extremely complex, layered in frequency, amplitude, and polarization, resembling something closer to executable code than simple communication. Tracking systems suggested the signal targeted a specific region of the Moon known for dense gravitational anomalies beneath its surface, areas called mascons. Meanwhile, strange patterns began appearing on Earth. Magnetometers across several continents recorded synchronized pulses every 43 seconds, matching the rhythm of SWAN's emissions. Seismographs detected ultra-low frequency vibrations that could not be linked to normal tectonic activity. Even migratory animals, birds, whales, and insects seemed to shift their navigation patterns slightly, as if responding to changes in Earth's magnetic environment. Whether these events were connected to SWAN or merely coincidence remains uncertain. Some researchers also began revisiting the mysterious 2017 interstellar visitor Oumuamua, wondering whether it might have been an earlier scout. Others noticed that both Voyager 1 and Voyager 2 briefly transmitted unusual bursts of data during one of SWAN's strongest emission cycles. If that observation turns out to be meaningful, then SWAN's arrival may not be the beginning of the story. It could be part of a much larger sequence, one that began long before humanity existed. The James Webb Space Telescope was built to study distant galaxies and the earliest moments of the universe. Yet its observations of SWAN and Atlas may be forcing humanity to confront something much closer to home. These two objects did not simply wander into our solar system like random cosmic debris. Their synchronized timing, strange maneuvers, immense energy levels, and sudden disappearance behind the sun's glare raise questions that scientists cannot easily answer. For the first time, humanity might not simply be observing the universe.